I decided to do a project on Nerf blasters. A Nerf blaster is a toy gun made by Hasbro that fires foam darts, discs, and foam balls. Nerf blasters work by using a spring located inside of the device and is compressed to store potential energy and is later converted into kinetic energy in order for the dart to launch in the air. The spring is held by a locking mechanism and is released once you pull the trigger, returning it back to its equilibrium point. Average gun weighs about 2.72 kilograms, and the size of a Nerf bullet is approximately 1 gram or 0.001 kilograms. Now it's time for the physics behind a Nerf gun. The average Nerf gun can shoot as far as 23 meters. So from all the information we have about this Nerf gun, we can determine the time it takes to travel this distance, the final velocity, and the horizontal acceleration of the bullet once launched. I was able to get the height of where the blaster would be launched by measuring how high above the ground my 5-foot cousin would have held it. Fun fact, 5 foot is the average age of 12-year-olds, or the age group that Nerf blasters are mainly purchased for. In order to find the missing values from the previous chart, we can use the following equations to help us out. As you can see, we have many of our y values, which include velocity initial, acceleration, and distance. We have our velocity initial, acceleration, and distance, and the only variable we can find with the given information is final velocity using the following equation given. For the final velocity for our y values, we figured out that it is equal to 4.55 meters per second. Now that we have our final velocity, we can find our time, which will be the same for both x and y. We can use the following equation to find the time. Our time for both x and y is equal to 0.46 seconds. Now we're able to find the whole velocity of the bullet now that we have both our distance and time using this formula. It was much more simple to find our velocity due to the velocity initial and velocity final being equal to each other. We got a total of 50 meters per second, and that's very, very fast. Here's an updated chart with all of the values that we have from using the different kinetic formulas. Now that we have all of our variables, we can now figure out how much kinetic and potential energy we have in the Nerf gun. These are the formulas that we use to find the kinetic energy and the potential energy found in the object. We get 1.25 joules as our answer for both the kinetic and potential energy, considering the fact that energy can't be created nor destroyed. Now that we know our kinetic and potential energy, we can now figure out what is the spring constant of the Nerf gun. According to my research, x is equal to 0.045. So the spring constant of the spring located inside of the Nerf gun, is 308.64 joules. Nerf guns work quite well considering the fact a small spring is responsible for all the work of launching a foam bullet a far distance. However, it can be quite dangerous because it launches 50 meters per second. When using a Nerf gun, it is best to wear proper equipment to prevent yourself from injury.